Hi everyone, welcome to my channel. So today I'm going to talk about a Smith chart, and basically I'm going to teach you how to plot impedances into Smith chart. So first let me just explain what is a Smith chart. So what is a Smith chart? Smith chart is named after Philip Hogarth Smith, and it is a graphical aid to solving transmission line impedance problems and to illustrate how parameters behave at given frequencies, and it is used for antenna problems and equipment displays. The Smith chart can be used to represent parameters such as impedances, admittances, transmission coefficients, noise figure circles, constant gain contours, Q contours, regions of unconditional stability, and etc. So it is the graphical equivalent or the geometry to mathematical calculations using complex algebra to match ladder networks to transmission lines. So now I'm going to teach you how to plot an impedance into a Smith chart. But first, let me just teach you or introduce to you about the Smith chart basics. So basically, a Smith chart consists of two intersection of two sets of orthogonal circles. Okay, so one set represents the normalized resistive component, or the R, tangent to a point on the right side of the outer circle along the center horizontal line. The other set is normalized reactive component, or the positive or negative JX, tangent to the same point but rotated 90 degrees clockwise or counterclockwise. So a Smith chart consists of two hemispheres. That is the positive hemispheres or the upper hemisphere, and the negative hemisphere or the lower hemisphere. Alright, so suppose we have here 8 impedances, which is the Z1 is equals to 100 plus J50, Z2 is equals to 75 minus J100, Z3 which is equals to J200, our impedance 4 is equals to 150, our impedance 5 is equals to the infinity, which is an open circuit, and our impedance 6 is equals to 0, which is a short circuit. And also we have impedance 7, which is equals to 50, and impedance 8 is equals to 184 minus J900. So to plot this into Smith chart, we have to normalize first the equations or the impedances. So if we're going to normalize this one, we have to divide that into divided by 50. Okay, so each impedances, we're going to divide this one into 50. So our impedance 1 will become 100 plus J50 divided by 50. That will be a 2 plus J1, and our Z2 will become 1.5 minus J2. Our Z3 will become J4. Our Z4 or our impedance 4 will become 3. Our impedance 5 will be infinity, as is infinity. And our Z6 will be as is 0. And our impedance 7 will become 1. And our impedance 8 will become 3.68 minus J18. Alright, so this normalized impedances, we're going to plot this into our Smith chart. Okay, so this is our Smith chart. Alright, so our first impedance is 2 plus J1. Alright, so we're going to locate this number or the R into this horizontal line at the center. Okay, so where's the 2 here? This is R2, okay, R2, and then we're going to locate this 1 into the outer circle here, okay. So as you can see, we have 0 here, 0 here, we have 1, 2, 3, 4, 5, okay. So we're going to locate the J1. We have 0 0.1, 0 0.2, 0 0.3, 0 0.4, 5, 6, 7, 8, 0 0.9, and we have now here the 1, okay. So we're going to get their intersection, the intersection of the circle and the intersection of this tangent circle. So it will be here, this one. So this is our Z1, okay. So next we're going to plot the impedance 2, which is the 1.5 minus J2. We're going to locate here the 1.5, which is this, okay, right. So since this is a negative J2, we're going to locate the 2 at the negative hemisphere or at the lower hemisphere, okay. So we're going to locate here the 2, which is this, right. So this one, okay. So we're going to get their intersection. So we have here this one, okay. So this is our Z2. Alright, so if you're new here in my channel, please click the subscribe button. So now we have to plot the impedance tree, which is the J4. So since there's no R here, we are going to just plot the 4. So we're going to locate the 4 here. Since this is a positive J4, so we're going to locate that one into the upper hemisphere. Okay, so we have 1 point, we have 1, 1.2, 1.4, 1.6, 8, 2, 3, and 4. So this is our impedance 3 or the Z3, okay. That's it along here. All right, so next we are going to plot the impedance 4 or the 3. This is R, so we're going to locate the 3 here at our horizontal line. So we have here 1, 2, and 3, this one. So this will be our Z4. Next, we're going to plot the impedance 5, which is the infinity. When we talk about the infinity, it goes around, since this is a 0, our horizontal line consists of the 0 here and positive infinity, which means it goes around here, all the way here. So the positive infinity will be here. So this is our Z5. And our Z6 will be 0. So we're going to locate the 0 here in our horizontal line. So we have 1, 0 0.2, 0 0.1, and here. Alright? So along 180 degrees. So this is our Z6. Okay. So next we're going to plot the impedance 7, which is the 1. So basically 1 here is along the center of the Smith chart. So this is the center. So we're going to name this Z7. Okay, so next is the Z8, which is 3.68 minus J18. So you can observe this one that it is a negative J. Therefore, we're going to locate that one at the lower hemisphere of the Smith chart. But first, we're going to locate the 3.68. So this is 3 all the way here, 3. Okay, so it goes around here, 3.2, 3.4, 3.6. Okay, around here. This one, okay. Next is we're going to locate the J18. Alright, so our J18 will be around here, 5, 10, 15, goes around here. Okay, so let's locate the tangency or the intersection of this one. Okay, 3. So it goes around here. So this is our Z8. Alright, so that's it. We have already plotted the all the impedances here. So we have here the Z1 or the impedance 1, which is equals to 100 plus J50. And we have here the Z2 equals to 75 minus J100. And we have the Z3, which is equals to J200. And the Z4, which is equals to 150. And our Z5, which is the infinity, simply like that. And our Z6 equals to 0. Our Z7 is equals to 50, which is the center of the Smith chart. And our Z8 is equals to 184 minus J900. So that's it. Thank you so much for watching.